Hello again everyone. So today we are going to look at a past year MCQ question for the A-level physics exam. Now this one was from last year, and I remember last year after the MCQ paper, many of my students were texting me to ask me what they thought about this question. And so here I am sharing it with you today. I actually think this is a pretty good question and you'll see why later. Okay, so let's jump straight into it. Okay, so here's the question that I was talking about. Please feel free to pause the video here and read the question first, and then later on I'll go through. Okay, so now if you've finished reading the question, basically what's happening is this object in the middle is split into two differently sized pieces, x and y. X is going to move over here, so this split happens again at t equals to 0. Then x will hit this side first at t equals to t1, and then after that y will reach and hit this side at t equals to t2. And then basically we're supposed to find out or describe what happens to the center of gravity of the system. So most of you will be thinking, okay, the first part of it at least looks a little bit familiar, right? It's an exploding object exploding into two pieces, right? So this object originally is at rest, so we can say that the original initial momentum is 0, right? And then when it breaks into two pieces, okay, we have mx with the velocity of x, right? And then add my plus the velocity of y. And then when you reach this point, then you get stuck. Because, well, we don't really know how x will interact with the container, okay? And how y will interact with the container, okay? So several things that you'll be wondering at this point is like, okay, there are three objects and then there are three interactions as well. So we have three objects, okay, x, y, and the container, and then there are three interactions. First, this thing at t equals to 0, then later on this collision at t equals to 1, and then another collision at t equals to 2. So, okay, three interactions. And then lastly, more problematic is the combined system center of mass or center of gravity. Now, this combined system center of gravity is something that we kind of have touched on in another topic on gravitational field. But in a situation like this where all three objects are potentially moving around, how do we tell where the combined center of gravity is moving? So this is where most of the confusion occurs. So this question is actually very good. I like this question a lot because it doesn't test you on your ability to do mathematics, okay? A lot of times students think that physics is just like a mathematics based, very mathematics heavy. You just take the equation, throw it at the question, and then poof, everything solved. Very good. So this is Cambridge telling you that no, it's not all about equations. It is about understanding. And here is what they want you to figure out. Look, they are talking about the center of gravity of the combined system. Now, how is the word system used in the principle of conservation of momentum? Now, think about this, right? Every time you do these equations, right, you're not just taking a memorized equation and throwing it at the question. What you're doing, right, is you are applying this underlying physics principle, which is the principle of conservation of momentum. And what does the principle of conservation of momentum say? It says that the total momentum of a system is conserved, meaning constant, right? Provided no net external force acts on the system. So what is the system in this situation? Is it x alone? Is it y alone? Is it the container? Or is it x and y as one system versus the container? Or is it x, y, and the container all together, right? So as you remember from the question statement, it is the system x, y, and the container. So all three things are a part of the same system. So how do we tie this in? Remember, the momentum of a system is conserved if no net external force acts on the system. Now, all the collisions that take place here, when x and y are forced apart, when x knocks into a container, when y knocks into containers, are all interactions between different components of the system. So all these forces that these guys, x, y, and the container exert against each other, right? All these are what we call internal forces. An external force acting on the system here would be gravity, okay? Exerted on each of these, because gravity is exerted by the earth, right, which is an object not inside the system, right, exerted on the system, okay, or friction or normal contact force, okay, all these other forces that are potentially exerted by external objects on our system. So the thing here is that if you look at this situation, it's a smooth surface indicating that there is no friction. There is, of course, everything has a weight, but the weight is always balanced by an equal and opposite normal contact force. So in reality, if you look at the system of X, Y, and the container, there's no net external force acting on the system, and so therefore the total momentum of the system is conserved. And what is the total momentum of the system? Everything started at rest, right? The total momentum of the system is 0. Momentum total equals to 0, right? And it will remain at 0. And so what does this tell us about the center of gravity? The center of gravity, the combined center of gravity, will not move. That's the only way that the m of x, y plus the container, right, does not have any momentum. Is that if the velocity of the center of mass is equals to 0. Okay, so the answer for this one is A. So to recap, the important learning points from this question is that number one, definitions are very important, okay? And not only are definitions important, attention to details of the definition are also very important. So make sure you understand very well what your definitions are actually talking about, okay? And then lastly is that Cambridge nowadays, they are not testing you about your ability to remember an equation and take the equation and throw it at the question and solve. No, okay, they want to test you on your depth of knowledge, okay? They want to test you how well you understand all these definitions and concepts that are being taught to you. Okay, so on that note, this is the end of the video. I hope you enjoyed that. I hope you found that useful if you are preparing for your promos, for your A's. And if you found it useful, please leave a like and subscribe. I will try to upload new videos every week or maybe every other week. Okay, so I'll see you in the next video. Thanks and bye-bye.